Hello students, today we are going to study Prim's algorithm in graph theory. So this Prim's algorithm is used to construct minimum spanning tree of a connected graph. So first we should know the basic terms, terminologies in graph. So what is meant by connected graph? So this is one example of a connected graph. So a connected graph is nothing but between any two vertices we have at least one path. So here any two distinct vertices are taken, then they have at least one path. For example, between A to E, we can have this path A to B and B to E. So what is mean by path? So path is nothing but it is a sequence of vertices and edges in which vertices and edges are used exactly once. So only one time only one edge should be used. No repetition of edges and vertices are allowed. So to reach A to E, we can use this path A to B, B to E. Otherwise we can go with A to D, D to B, B to E also. We have so many paths. So here all the vertices are joined by paths. So this is an example of a connected graph. So from this connected graph, using Prim's algorithm, we are going to form one tree, minimum spanning tree. So first, what is mean by a tree? Tree is nothing but it is a connected acyclic graph. So connected we know between any two vertices we have at least one path. So what is acyclic? Acyclic means it has no cycle, that is no closed region is there. So this is example for one tree. Okay, because from A we can reach B, from A we can reach D using this path A to D. From A we can reach C, that is A to D and C to B. From C we can reach F. From A also we can reach F, A to D, D to C and C to F. So between any two vertices we have one path. So this is a connected graph and it has no cycle. So this is example of a tree. So what is mean by spanning tree? So here minimum spanning. So spanning means in this connected graph we have A, B, C, D, E, F, G. So totally 7 vertices are there. So in one tree all the vertices are present. In what are the vertices present in the connected graph? All those vertices are assumed in that tree. Then that tree is known as a spanning tree. So spanning tree is consisting of all the vertices of a given graph. A tree consisting of all the vertices of a given graph is known as a spanning tree. Okay, so using Prim's algorithm for any connected graph we are going to construct one spanning tree. So first we will see the algorithm. Okay, so first step. So what is first step? Any edge of the given graph G with the smallest weight is chosen and put into the spanning tree. So initially we are taking any edge which has smallest weight, so that one is selected and taken in the spanning tree. Okay, and then in next step, step 2, edges of minimum weight that are incident to a vertex already in the tree. Okay, so already we selected one edge, so edges joining two vertices, so two vertices are available. So from what are all the edges starting from those two vertices, all those we have to consider except the already selected edge. Okay, remaining all the edges we should consider, and with minimum edge with minimum weight is going to select for next iteration. Only thing we should concentrate is that selection need not form a circuit, that is one closed diagram. Okay, so those things we should concentrate. And not forming a circuit with the edges already in the tree are added successively. So successively we are adding one by one. Okay. And then third procedure, third step, the procedure is stopped when n minus 1 edges have been added. That is, so these three are steps for Prim's algorithm. So we can explain this one in this way also. Okay, so first thing is we are mentioning our vertices by v1, v2, etc. Bn. The weight matrix W of G is formed. So we have to form one weight matrix with infinity as the weight of any non-existing edge. So if one edge is non-existing, then that weight is taken as infinite. Okay, so with this idea we have to form weight matrix of given graph. Then we start with vertex v1. So initially we are starting with v1. Okay, so list all the eligible edges on v1. So from v1 vertex, what and all edges are emerging, all those edges we should list first. Okay, so among that list we have to select the least weight edge. Suppose we say that least weight edges v1 vj. So we are initially selecting the edge v1 vj. Okay, so for our spanning tree. So now we have two vertices in that selection. One is v1 and another one is vj. So we should mention all the edges which are incident with v1 and vj. So initially all the edges incident with v1 are entered. So we should take account the edges which are incident with vj except this v1 vj. Okay, because that one is already selected. Okay, among those list, that is some set of edges incident with v1 and edges incident with vj. So among these edges, that is from old collection as well as from new collection. So together we have to consider in this next step except the already selected ones. Okay, so among those edges take the edge with least weight. So that is for the next selection. So each time we are considering one edge which is going to incident with already selected vertices. So those things we should remember in this Prim's algorithm. Okay, so when we have to stop this procedure, so we have to repeat this procedure until all the n vertices are connected by n minus 1 edges. So we are having all the n vertices in our tree and having n minus 1 edges, then we can stop our procedure. Those selected edges form a minimum spanning tree. Okay, so this is Prim's algorithm. So now we are going to explain this one with the help of one graph. Okay, so our problem is this one. Use Prim's algorithm to find a minimum spanning tree for the following weighted graph. So why we are calling this graph is weighted? Because each edge is assumed by some weight. So this is one weighted graph. So totally we are having 7 vertices, namely A, B, C, D, E, F, G. Okay, so for this connected graph, we are going to draw one spanning tree, minimum spanning tree. Okay, so initially we should form a weight matrix of this connected graph. So consider all the vertices. So totally 7 vertices. So we are taking that vertices in rows as well as for columns. So first one is A to A. So between A to A, no edges existing. So we know for non-existing edge, the weight is assumed as infinite. And then between A to B, one edge is existing and weight is 5. So that one is taken as 5. And then A to C, yes, A to C, one edge is existing, which is whose weight is 4. And then next A and this D vertex. So between A and D also we have one vertex edge. So weight is taken as 1. Okay, and then A to E. So A vertex is here, E vertex is here. So between A to E there is no direct edge. So these two vertices are non-adjacent. So between A and E, no edge is existing. So by assumption, this value is infinite. Next A and F. So between A and F also no direct edges there. So for non-existing edge, the weight is assumed as infinite. Next A and then G. So A is here and G is here. So between A and G, no edges emerging. So this is also taken as infinite. So likewise we have to fill remaining entries of this matrix. Okay, and then we are forming one table to find the minimum spanning tree. So first column is iteration number, next one eligible edges after ith iteration, and next one is selected edge with weight. Okay, so first iteration 1. So we are starting from initial vertex, namely A. So what and all edges available? AB is available, AC is available, AD is available. These are numbers, remaining are infinite. So only these edges are emerging from vertex A. So we are considering those things with weight in mention in the bracket. Okay, so AB whose weight is 5, so we are taking AB 5, and AC whose weight is 4, and AD whose weight is 1. Okay, so without box only initially we are having, because I completed all the table columns, so all are mentioned here, but initially we are writing only edges. Okay, after selection only this boxes are made. Okay, so among these weights, one is 5, 4, 1. So which one is least? So AD is obviously least. So the selected edge with weight is taken here. So we selected AD whose weight is 1. Okay, so at each stage we have draw that spanning tree also. Sorry, tree also, not this thing is a spanning tree. It is tree. Okay, so we selected two vertices. One is A and another one is D. So between these we have edge AD whose weight is 1. So in this, after this iteration, this AD edge is selected. Okay, so now we are left with two vertices. So one is A and another one is D. So next edge should emerge either from A or from D. So we should write all the edges which are emerging from vertices A as well as D. Okay, so all the edges which are emerging from A are already mentioned. So now we are going to write the edges which are coming from vertex D. Okay, so go to this one. So totally we have 1, 2, 3, 4, 5, 6. In that this one is already selected between A to A. That is already selected, isn't it? So don't repeat that one. So remaining things we have to write. So D to B 14, D to C 3, D to what? Yeah. E. So D2E 8, D2F 12, D2G 9. Okay, so all those things are mentioned here. Okay, so now we are having, we have to consider these two vertices, that is A as well as D. Both this AD is selected. So omitting this AD, remaining all edges should be considered. So we are having AB, AC, DB, DC, DE, DF, DG. Okay, this one is 5, 4, 14, 3, 8, 12, 9. So among these weight, this 3 is the least one. So next edge we are going to select here is edge DC. So DC is selected because that one is having small weight. So DC is selected, whose weight is 3. Okay, so now the graph for this one is already AD is there. From D we are taking C. So D to C is taken. So each edge is emerging from already existing vertices from our tree. Okay, so that thing we should concentrate. So this is in the second step diagram. Okay, and then now we have 3 vertices. One is A, D and C. So we have to consider all the edges which are coming from these 3 vertices. So all edges from A are here, edges from D are here. So only thing is we have to consider edges from C. So we are going to write edges from C. Okay, so in that C we have CA, which is already taken here, AC, that is so don't take this one. And then next CD, that CD is also taken here, that is also used, so don't take this one. And the next one is CF, so whose weight is 6. Okay, so next we are taking CF. Okay, so now the selected one is AD and DC. So these two only selected. So we are left with AB, AC, DB, DE, DF, DG and CF. Okay, weights it is 5, 4, 14, 8, 12, 9, 6. Okay, among that least one will be AC. AC is the least one, whose weight is 4. Okay, but if we select AC here, then already A, D and CD is like this. If we join A and C, then that one form one cycle. But our thing is tree. So tree has no cycle. So cycle is formed here if we select the least weight edge, namely AC, whose weight is 4. So that cycle is not entertained. So we should not go for this AC. So we are moving to next least one. So next least one is 5, isn't it? So we are taking this least weight edge, namely AB. Okay, that is already we have AD and CD. Now we are having AB. So from A we are taking this B. So vertex, so AB edge is selected. Okay, so now we have 4 vertices, A, B, D and C. So already A, D, C, whose emerging edges are mentioned here. So now we have to go for the new vertex, namely B. So what and all edges emerging from B. Okay, so BA already mentioned here, so don't take this one. And then BD also already taken. So we are going with BE. Okay, so BE whose weight is 10. That alone we are not listed in this sequence. So we are having BE which is 10. Okay, so now we have to consider this one is not possible. These two are selected and this one is also selected. So we are left with DB, DE, DF, DG and CF. Okay, all these edges we have to consider. So this one is 14, 8, 12, 9 and 6. So among those least weight will be the 6 only. Okay. So we have to select in this iteration this edge CF is selected. Okay. So from C, previous step we have this tree. Now with the C we are joining edge CF. So from C one vertex is included, F and CF edges joined here. Okay, so this is our current status after fourth iteration. Okay, so we have namely A, B, D, C, F. So only new vertex here is F. So what and all edges emerging from F, all those we have to consider. So from F we have FC, that one is included initially, and then FD, that is also mentioned here. FD, yes, FD also mentioned, but wrongly we have taken FD. No need to write FD here. Okay. So only thing is we can have this F and G, which whose weight is 2. So F and G 2. So no need to take this FD because this one is here. Okay, so this is wrong entry. So only FG is available here. Okay, so this one selected, this is not possible, selected, selected, selected. So we are left with DB, DE, DF, DG, BE and then FG. So among this 14, 8, 12, 9, 10 and then 2. So this 2 is the least one. So we are going for FG edge. So previous step, this is our diagram. So with that F we are extending one edge, namely FG, whose weight is 2. Okay, so now the new vertex included here is G. So we have to consider the edges coming from G now. Okay, so from G, so we have CD, GD, which is already taken, GE, that one we have to consider because that vertex is not mentioned. So GE and GF, that is already included. So only thing is GE. Okay, so the edges we have to consider now is DB, DE, DF, DG, BE, FD and GE. So among that the minimum weight will be GE. So we selected GE. So from this G we are going to introduce one new vertex, namely E, and that one is joined by GEH. So all the so totally 1, 2, 3, 4, 5 and now one more we are going to introduce. So 6. So 7 vertices are there and 6 edges we constructed. So this is our spanning tree. Okay, so since all the 7 vertices are connected by 6 edges, that do not form a circuit. The edges of the spanning tree are so we are forming in one order: BA and then AD and then DC, CF, FG and then GE. Okay, so this is our spanning tree. Weight of the spanning tree will be adding all those selected edges weight, we get the weight is 24, and the diagram for this one is BA, and then AD, next DC, CF, FG, and then GE. So this is a connected graph without a cycle. So it is a tree. Since this tree consisting of all the 7 vertices of given connected graph, so this tree is known as a minimum spanning tree. So Prim's algorithm is used to find minimum spanning tree for any given connected graph. So in this algorithm, in each step we are going to join one new edge, which are the vertices which are available in the already existing graph. With that only we are going to join one new vertex. So that differentiation we should know, because one more algorithm is there, that is Kruskal's algorithm, that is also used to find the spanning tree. So we will study the procedure in next video. Thank you.